Hopefully everyone can see that okay. So my name is Simon Walker. I'm the Public Cloud Service Director here at Bytes. So I have the overall responsibility with the relationship with Amazon. Really excited today to be talking to you about Veritas and how we work with Veritas and Amazon, talking about all the benefits around that, some services that we can actually offer you. In terms of people we've got some excellent speakers today. We've got Tom Sargent from AWS, who's basically going to give you a bit of an overview of all the new advancements in storage integrations with partners like Veritas. And we're over to Richard Holbkirk of why Veritas for AWS. Then we're going to have a short break, just a comfort break, and grab a coffee, whatever, for about 10 minutes. And then we're going to jump back on again with Colin Hinks, talking about data protection and in AWS, then across to Peter to talk about availability and disaster recovery in AWS. And I'll finish up with a bit of an overview of the Amazon practice here and how we can support with different funding offerings and services. But without further ado, I'll hand over to Tom Sargent.
Thanks very much. Good morning, everyone. So my name is Tom Sargent, and I'm something called the Storage Segment Lead for EMEA, which means I care a lot about storage in AWS, a lot about storage partners such as Bytes, who help customers, you guys, on their path to AWS, and Veritas, who help drive a lot of backup storage, a lot of primary storage, and all manner of different applications into our platform. So I'm going to go through a really quick 101 of the AWS Global Infrastructure. Then I'm going to go through a really quick 101 of the storage building blocks that we have at AWS. Then I'm going to talk about protecting workloads to and in AWS really quickly, but I'm not going to take any of Veritas's thunder there. We're going to talk about some broader integration points, so how we integrate with partners across a myriad of different services and why partners are so important for AWS. And then I'm going to hand over to the next speaker to carry on after me. So I'll be going for about 10 minutes or so. Feel free to drop any questions in the chat. Someone might have to read them to me, but I'm keeping half an eye on that. So let's think about what the global infrastructure looks like. Oh, sorry, obligatory Gartner slide saying how amazing we are. So AWS have been a leader for 11 straight years in the Gartner Magic Quadrant, and I'll kind of explain why when we get into the storage services piece. So back on track. Our global infrastructure is pretty big. We've got regions and availability zones within those regions, pretty much everywhere where there are major customer presence. So those little blue circles are where we've got regions today, and the little orange circles are where we're going to be delivering regions over the next couple of years. So most of the people on this call will be really interested in UK. So we've got a region in London and a region in Dublin that are geographically close to the UK and offer lowest latency connections. So I've used a couple of terms there, region and availability zone. And I'm going to explain what they really mean, because for us, they've got a particular meaning. And for others, it's maybe a slightly different meaning. So in the AWS nomenclature, a region is a physical location in the world where we have multiple availability zones. And then an availability zone is one or more data centers with redundant power, networking, all that kind of stuff, housed in separate facilities. So this diagram here shows it at a really high level. Let's say this is the London region, LHR. It may comprise a number of separate data centers, which are just close enough to ensure super low latency replication between them, but they're far enough away that if there's a major event, it'll only impact one of the availability zones. So regions have many availability zones, depending on the part of the world that we're in. It's usually a minimum of 3, but it goes up to quite a few. And some providers have much fewer availability zones for resilience. And so we have to consider that when we're building our storage services. We have to ensure that customers understand what replication means, what availability means, what uptime means, all those different terms that come up quite a lot. Maybe you're used to having 2 data centers on premises and doing DR between them. So you might understand that you have to take some sort of action in the event of an infrastructure failure. We encourage customers to plan for failure and plan for an availability zone maybe not being available at some point. So if you plan application redundancy, we can help you ensure that you remain up if there is an availability zone issue for any reason, or if one of your services fails in a particular availability zone and your application, as I say, remains up, serving your customers and keeping your business running. So how do we design our availability zones? Well, it's fully isolated infrastructure. You can read off the slide. Basically, hundreds of thousands of servers in a data center, which hook it up to another data center. Some of our services are what we call multi-AZ, which means they're resilient at that geo level. And some of them only operate within a single availability zone. So if that's the case, you've got to work out how you're going to ensure that your service remains resilient. If we provide a multi-AZ resilient service, then we do a lot of that automation behind the scenes for you. So we've got super fast networking between each of our availability zones, at least 2 redundant transit centers, which is really how we get the data in and out of a region. And we've got, well, basically everything connected to everything. So we can mitigate against any connectivity failures on a single route between availability zones. Now, thinking about how we string everything together on a global basis, we've got our own 100 gig redundant network, private capacity between all regions except China, because we have to be a little bit cautious there. We've got something that's also called Direct Connect, which is where customers can reach every region from their local Direct Connect point of presence. And what Direct Connect means is you've got a private link direct into an availability zone or region that gives you a really high speed, low latency link, so you don't have to go over the public internet. And I think that's something that's going to come up a little bit later, and how that can be used by third parties such as Veritas to increase connectivity from on-premises into our environment. So that's enough about the region stuff and the AZ stuff. Let's just think briefly about AWS storage and how it's a fundamental building block for every other AWS service. So you may have heard of object storage, or S3. This was the first service that was really publicly available some 15 or so years ago. We're #1 in object, which means we store more objects and a higher volume in terms of storage capacity than anyone else. We're #1 in block. So we provide something called EBS, or Elastic Block Storage, which is, it's kind of like having a hard drive that can connect into your EC2 instance or your virtual server instance. And we're #1 in file. So we've got this huge cloud storage portfolio where we're able to use NFS, we're able to use Windows file servers, which are actually virtualized in AWS. We've recently announced something which we call Amazon FSx for NetApp ONTAP. And what that is NetApp ONTAP running natively in AWS and giving you the scalability of AWS with the power of ONTAP. So we're always looking to integrate more third-party solutions to really help customers get the best of their traditional on-premises infrastructure and the best of AWS. So we've talked about the right class of storage for any data. We also need to make sure that we keep costs down as you move data into the cloud. So let's think about traditional storage. And this little column in the middle represents the kind of the cost of all the hard drives. So everyone's got to buy hard drives. We don't get much difference in price in terms of the storage that we buy than any other vendor. Now, in a traditional storage infrastructure, we need to worry about migration between storage appliances when they reach their natural end of life. So 3 years, 5 years, maybe you got to buy another one, got to migrate the storage. There's often an issue around underutilization. And that's where you've got to think about how much storage you may need over the next 2, 3, 4 years. Maybe you've got to buy all that up front. So you're only actually utilizing a small amount of that for your live data on day one. Maybe you've got to think about the human resources element. And yes, that's the administration cost of the storage. It's swapping the hard drives in and out. It's all that kind of stuff. Then maybe there's the hardware and software maintenance. So when you get to the end of that first 3-year period, maybe you're thinking, oh, can't replace it. So you've got to renew your hardware and software maintenance for another year or two to ensure that your equipment is usable, compliant. There's usually a network cost as well. So you've got to buy your switches to connect up to your storage. And something that's often not factored into a lot of TCOs still is the data center space. So power, cooling, the actual cost of the rack, the actual cost to rent the space. And that can all lead up to a larger on-premises cost than you necessarily think. Now, at AWS, we do add some cost onto that base storage cost as well. So we have a data transfer cost, and sometimes we have a request or retrieval cost as well, depending on the class of storage. But that's effectively paying for the infrastructure on a pay-as-you-go basis. So rather than charging you $50,000, for example, maybe for a fiber channel switch, we charge a really small amount for any read or write to one of our lower long-term retrieval classes of storage. So typically, we can demonstrate that the cost to store data in cloud, once we factor in everything, is going to be much lower over a longer period of time because of our economies of scale. We can actually express this a slightly different way, and this might make a bit more sense to some of you. Think about traditional storage array. You need 600 terabytes, so you've got to allocate that up front. Maybe you're only using 400 terabytes today. So with all your RAID, you probably get to about 800 terabytes, and you have to buy a petabyte up front. So you paid for a petabyte over 3 years. In AWS, you just pay for what you're using today. So it can be much more economical because you're not paying for that petabyte for maybe the first couple of years. You're only paying for what you actually use. So just thinking about that broad portfolio of offerings that we have, I've mentioned S3, mentioned EBS, mentioned all this file stuff. Now we do actually have our own backup service, but it's not as sophisticated as people who've got a lot more experience with other services. So it's not really something that we tend to see a lot of on-premises customers using. It tends to be things that maybe digital native businesses are using as they just start their journey with AWS. And a lot of vendors can actually plug into that infrastructure. I do want to touch on data transfer and migration, because we do give customers a lot of different ways of getting their data in and out of AWS. And you may hear about some of them a little bit later from either Petter or from Colin. So we've got something we call Storage Gateway, which is exactly that. It's a gateway that looks like it's local native storage, either a tape array or maybe file gateway, that then stores data in AWS. So it caches the hot data. We've got Data Sync, which is a service where you can get data in and out. We've got the data transfer family. We've got Snowball, we've got Snowcone. So these are pretty interesting. The Snowcone devices are little multi-petabyte devices that can pretty much be mailed. So you could do your local storage updates onto a local device, then you can physically transfer that to AWS, and then it gets integrated into the right service there. And one of the funniest demos we've ever seen is there's something that was called a snow truck, snowmobile, I think it might have been, which was a kind of a juggernaut sized lorry full of racks where we could go to a data center, pull out all the storage, drive it to an AWS data center, ingest all the storage and keep going. I think that was on pretty grand scale, but we see customers opting to have multiple of these smaller devices to transfer data over a longer period of time, because that tends to be much more cost effective. So that's just the underlying building blocks and how you might get data in and out. Let's think about what customers are really building, because a lot of the time you don't care about the underlying infrastructure in cloud. You just want to know that your data is available, your application's available. And some of the applications that I see customers building every day, and I'll go from right to left actually here, business critical applications. So your payroll systems, so everyone gets paid, brilliant. The things that help your company actually make money, and that'll vary drastically between different companies, different verticals. Modern applications. So I see a lot of customers really moving into containerized solutions, serverless solutions. This isn't all about AWS, so I won't go into too much detail there, but feel free to ping me and I can put you in the right direction afterwards. Data lakes for AI ML. S3 tends to be used a lot here, where we want to store an awful lot of data so we can run analytics and maybe run data warehousing and look at long-term business forecasting based on a very diverse data sets. Home directories as well. So as customers rely more on cloud, a lot of the traditional on-premises NAS is coming into cloud. And you can see that theme across multiple different vendors. So you'll be familiar with, for example, OneDrive, you'll be familiar with Google Drive. We offer the platform for vendors to build on top of, and we integrate third-party solutions. I've already mentioned NetApp, for example, for FSx for NetApp ONTAP. We've got FSx for Lustre, really high-performance Linux file system, etc., etc. Possibly archive and compliance. And this is actually a really huge area for us around media workflows, as our broadcasters are coming onto the platform. As a lot of public sector organizations have to demonstrate they're storing data for longer periods of time than ever. GDPR comes into this then. So how do we make sure that GDPR data is scrubbed? We've got some solutions for that. A lot of third parties plug into that as well. And then backup and restore. This tends to be one of the first entry points for customers looking to move into cloud, because it's often very easy, and I actually dig right into that next slide. It's often very easy to take that first step into cloud with a cloud connector from your favorite backup vendor. A traditional backup may rely on appliances or tapes on premises. A more modern approach maybe to either use the vendor hardware or AWS gateway to be that bridge into cloud. And then you may actually start to integrate something we would call a cloud connector into your workflow, where you can then natively write data into probably S3, read it out again if you need to. And this is an amazing approach to actually begin a migration of workloads into AWS, because once you've got your backup data in AWS, if you need to restore it for any reason, you've got the decision to make. Do you restore it back on premises, or do you just spin up a temporary instance in AWS, effectively connect to that backup, pull out what you need and keep going? Or maybe you decide that you're going to start that workload in AWS and keep it in AWS because it makes sense to do so. Or maybe you can move your DevOps into AWS and use your data protection technology to keep a regular copy updated in AWS, do your DevOps up there, because you can spin it up, blow it away. You only ever pay for what you use at the point in time that you're using it. Now, cost, again, I'm coming back to cost, sorry, it's a major factor. We've demonstrably decreased our storage prices about 80% over the last 15 years. And we've done that through the introduction of a number of different storage classes. So S3 is S3. Everyone's moderately familiar with that. But we've got a lot of different classes within S3. We've got standard going right up to something that we call Glacier Deep Archive, and maybe even intelligent tiering. And what happens is, as the access profiles of your data need to change over time, maybe today you need really fast read and write access to some data, but you don't need fast read and write to really old data, like maybe tape backups. So you can put them in a lower class of data, and we'll charge you a lot less for storing that data. All our pricing is public, so you can go and work it out on the calculator what the difference is. But we may charge a small cost for retrieving that data, because if it's archived data, we think about on premises, there's similar cost of maybe restoring a tape from an Iron Mountain. Not picking on them for any reason, they just sprang into my mind. Your data restore workflow, you'd have to make a request to the vendor, you'd have to physically ship the tape back, then you need to restore it. So we've thought about that sort of workflow as well. And if we've got effectively offline or data that's going to take 24 hours or so to retrieve, there may be a small cost associated with that, but we're really transparent about those costs, and Veritas can certainly help you model those costs if you're looking at any cloud migration activity. So I'm not going to bore you about every single S3 class. Let's talk a little bit about Storage Partner Solutions, how we work together with ISVs, in this case, Veritas. So you can see the bottom tier there has got all the underlying AWS storage infrastructure. Partners can plug into that with our storage APIs, and then they can integrate with a whole plethora of other AWS services. And in particular, we see a lot of people use S3 Glacier for storing data for data protection or data lakes. We see a lot of customers using Storage Gateway, maybe as that bridge to cloud, if they're not quite ready to use a native solution yet. And then through a series of complex APIs, maybe we can connect into other storage services and database engines as well. You don't want to hear about all this from me, so I'm going to stop at this point. I'll be available on the chat for most of the session if you want to ask me anything in particular. I'm going to hand over to the next presenter, who's going to start to dig into some of those integrations and some of how they'll help you on your cloud journey moving forward. So who's up next?
That would be me, sir.
Fantastic. I think you can steal the ball from me.
Excellent. Bear with me 1 second while I just share my screen. So thank you very much, Tom. Apologies, while I bring my slides up. Excellent. Can you see that okay?
Yeah, all good.
Wonderful. So thank you very much, Tom, and good morning, everybody. Just a very quick introduction to myself, and apologies where I'm sitting. I'm sort of backlit, so I look a little bit silhouetted on the camera, so it's not ideal. So I am the technical sales manager at Veritas. So that means I have I manage a team of solution SEs who cover the breadth and depth of our portfolio. I've been around Veritas and Symantec for approximately 15 years or so. Now, unfortunately, not long after I finish speaking, I will have to drop off the session because I have a clash, but I have plenty of colleagues on the call. So we have Colin Hinks and Petter Svaum, who will be running through in more detail than my own session, different areas of our portfolio. And then we also have Lee Mollett and Andy Dunn on the call, who will pick up any questions that anyone would like to address to me, and I will respond after the session. So today I wanted to give a high-level overview of Veritas and our partnership with AWS before Colin and Petter go into more detail. So a lot of customers have heard of Veritas, but probably in the context of a subset of our portfolio. So I wanted to take the opportunity to give you a sort of overview of Veritas and what we do. So this is effectively Veritas on a page. So we've been an industry leader in the solutions that we offer for approximately 30 years. For example, one of the things that a lot of customers will know about Veritas is that we do backup and recovery. We've been a market leader in that space under Gartner for 16 years in a row. Likewise, with information archiving, 14 years in a row. But to give you a bit of context about Veritas as a company, we are ever present in about 87% of the Fortune 500 companies. We are 90% upwards in Fortune 100 companies. So we're trusted by some of the biggest and most complicated customers in the world to manage and maintain their data. We have approximately 6,000 employees worldwide. We have a partner network, of which Bytes are one of our top partners in the UK, of 20,000 plus partners globally. We have a huge install base of 80,000 plus customers. We spend a lot of our money on making sure that we continue to innovate. So we talk about a 30-year heritage. It's difficult in a fast-moving industry like ours to maintain that leadership without continuously innovating. So we do spend a lot of money on R&D and innovation right across our portfolio. So we maintain a lot, a large percentage of our employee base is developers. We have a huge number of patents that we are continuously registering, and we ensure that as the industry changes, as new technologies emerge, and as new workloads emerge, we maintain the broadest support for those workloads. So 800 plus workloads that we can effectively manage and protect the data for. We have a huge amount of install base across those 80,000 plus customers with over 100 exabytes of data under the management of Veritas. So that gives you a sort of context of Veritas in terms of the sort of scale of organization we are, the sort of leadership position that we have. And if I sort of compare that and steal a little bit of Tom's thunder earlier, this gives us a really, really good alignment to AWS. So we have a very strong global partnership. So some of the things I talked about Veritas's leadership position, Tom talked about in his presentation, that AWS are absolutely the leader in that cloud platform. So we have a very, very strong alignment in terms of that joint position of leadership. So if I touched on the R&D figure earlier. I touched on the patents in my intro slide. We spend approximately $250 million per year on R&D. So why is that important to you? Why do you care? It means that we continue to innovate. It means that whatever workloads you decide you are going to put into your environments or going to drive your critical applications, or maybe something that you're going to look at in the future as you embark on a digital transformation journey, effectively Veritas has you covered. In the context of AWS, we support all of the storage use cases, the competencies, if you like, that vendors such as ourselves can partner with AWS on. So if I delve into that just a little bit deeper, we are the only partner who support all of the AWS storage use cases. So backup, as I mentioned at the beginning, that is probably what we're most known for in terms of our customer base, or anyone who's heard of Veritas. So that's something that Colin will be delving into in more detail a little bit later in the session. When we talk about disaster recovery, and actually on the right-hand side of the screen as well, high availability. That's something that Veritas have been leading with, regardless of the customer's infrastructure, for 30 years. And Petter will be delving into those sections in more detail. Tom talked about some of the migration capabilities that AWS have natively, some fantastic tools. But we also have some really strong capabilities to assist customers to get their critical workloads into AWS. And we can often do that with minimal to no downtime and in a secure way. So critical applications can be moved into AWS with effectively an assurance to the customer that they can test that migration, they can do rehearsals without impacting the production system until such time as that they are completely confident that they can effectively flip the switch, and that workload will go from on-prem or wherever it exists today, could be another cloud, into AWS, and then that is now the production system. And archiving as well, as Tom said, that's along with backup, usually quite a good entry point into AWS to take the cost of managing and storing older and legacy data, or data that must be retained for compliance purposes, or if the customer's in a regulated industry. AWS is a really, really effective way of storing that data for long term, and we fully support that archive use case with our technology. So if I put a little bit of context in terms of, and this is the only product slide I have, in terms of referencing some of that with our technology. So in terms of data protection, you know, we're very much talking about the context of AWS today, but we're very aware that most customers will still have a hybrid environment, and it may be that their direction of travel is, and it's more common that the direction of travel will be to move as much as possible into the cloud. Well, not only do we support that and help customers transform in that way, but we can do that across whatever their infrastructure looks like. So we support their on-premise workloads in terms of all the use cases we talked about, and we support them as they migrate into the cloud, and we help customers migrate into the cloud. So if we talk about some products here, we have as I mentioned, the broadest support of workloads, but we also have the broadest support of infrastructure choices as well. So we don't really care what applications customers use, we can help them. We don't really care that if in their data centers they have a mixture of physical infrastructure, virtual infrastructure, what their databases might be, what their hypervisor of choice might be. We support pretty much everything that's available, and we can protect those workloads with our Net Backup, which is our flagship data protection technology. Colin will be delving into that a little bit more. We can ensure that we keep critical applications and the most critical money earning workloads available and highly resilient, and that again is from an on-prem perspective right through to in AWS, and that's what Petter is going to delve into a little bit more. And then if I talk about the next two elements on here, so that's Enterprise Vault and our data. Oh, sorry, is there a question or is that?
Okay.
Oh, I think.
No, don't worry about it. We just need to know. Yeah, just.
Sorry, I'll just mute that one. If I talk about Enterprise Vault, which is our archiving technology, but expand that into another technology we have called Data Insight. That is a technology that helps customers understand data. Now, as we're not going to be delving into that in any great depth today, I will spend a couple of minutes just talking about the capabilities there. So, for example, customers who might be early on in their cloud adoption or cloud migration strategy, one of the first challenges they face is understanding what their environment looks like today. So this particular part of our portfolio with DI and Enterprise Vault, we can help customers understand exactly what their data looks like. And that's a particular challenge with customers with unstructured data, because that tends to be often 80 to 90% of a customer's data sphere or data footprint tends to be unstructured data. Customers, you know, we're all digital creators. We are all creating new unstructured data all the time. So it's difficult for customers to really keep on top of what their data looks like, who owns it, who's got access to it, is there any risk around it? So with our Insights portfolio, of which Enterprise Vault and Data Insight are part, what we can do is we can effectively shine a light on that customer data. We can analyze that data, we can show the value of that data in terms of who's using it, when was it last accessed, is there any risk around it, does it contain sensitive information, does it contain PII type information, you know, where does it reside, is there any anomalous behavior around the accessing of that data. For example, you have, you know, we have a built-in classification engine to most of the products in this part of our portfolio, with over 100 digital compliance laws built in effectively. So for example, I'll give you a really quick and easy crude example. If you wanted to find anything that contains driving license, credit card numbers, anything like that that could be attributed to personally identifiable information, you could just check a box in our policy engine and our technology will just go and show you where that data is in your environment. Very, very useful for customers who are thinking about moving as much as possible into the cloud, because it could be that actually they're retaining some data, and quite a lot of data usually, that actually could be archived or even deleted if it serves no business value. So typically when we go through this exercise with customers, we're able to completely eradicate, if you like, or delete about 30% of their data. So we can normally offer a fairly quick cost saving to customers when they are going through a transformation of infrastructure, such as a move to AWS. We can look at what we would class as rot data, so redundant, obsolete, or trivial. We can show them where their sensitive data is, get rid of the rot data, and therefore help them reduce costs as they move into cloud. The second part of our insights portfolio is our IT analytics platform. And this is a platform that, so the things I've been talking to up until now in that part, so Enterprise Vault, Data Insight, that's all about data. It's about understanding data. The second part of that portfolio is the Aptar and IT analytics platform, and that is about understanding infrastructure and understanding cost of infrastructure and understanding, for example, showback and chargeback and how well everything is performing. Again, we're not going to go into that in great depth today. If anyone is particularly interested in any of those topics, please do let us know in the chat and we can organize a separate session to talk about that. But Aptar IT Analytics effectively shows customers what their infrastructure looks like, and that can be right across the full hybrid spectrum. So that can be on-premise, it can be AWS cloud, it can be another environment, and Aptar will effectively show everything that the customer is using from an infrastructure perspective in terms of what it's costing them, are there any risks around it, what the trending looks like in terms of both utilization and cost, how many copies of the data are being used in terms of showback and chargeback. So for example, I'll give you another crude example. If a customer has a database workload, that is often considered in terms of cost. What does the storage infrastructure look like? What does the server infrastructure look like? But quite often people don't think about, well, how much is it? How many copies am I backing up? How much am I replicating? Where am I storing it? What tiers of storage am I storing that data on? How many copies are being spun off for DevOps or other use cases? All of that has a cost associated with it, and Aptar IT Analytics can effectively illuminate that for a customer from end to end, showing them the true cost of what running a particular business service is to that customer. And again, regardless of what the application stack, what the infrastructure looks like in terms of customers who are well on their way to having as much as possible in AWS versus a more traditional on-prem approach or anywhere in the middle, all of these solutions work right across the stack. So if I break it down, and this is my final slide really, these are the areas where we really help customers across that portfolio. So the first is to help them actually transform. So as customers would like to migrate and move more workloads into AWS, we, through our heterogeneous agnostic support for so many different workloads and infrastructures, we can increase the agility of those customers in terms of speeding up their ability to move workloads into AWS with huge amounts of uptime, as we've already talked about, and Petter will go into a bit more later. The ability to effectively make critical workloads portable, so the ability to pick things up, move them from on-prem into AWS or multiple clouds if necessary. The ability to rehearse and orchestrate recovery so that customers have that confidence that their critical workloads are protected and that they can recover at scale in the event of something going wrong, and the ability to integrate regardless of what their infrastructure choices are. Protection, as we talked about, and Colin will go into in more depth, we are market leaders in data protection, is what we're probably most known for. So providing a unified platform that will allow recovery from anywhere to anywhere, regardless of what the customer's infrastructure choices are. And the ability to provide things like self-service, role-based access, granularity of recovery. Customers can recover, individual files or individual parts of data versus actually the ability to recover at scale an entire data center if need be. And then native capabilities that we have. So we have a quick example here for customers who are concerned about ransomware and are looking to move into cloud. We have a technology compatibility or tie-in with AWS where we fully support the S3 immutable storage tier, the object lock. So if customers would like to use data protection, as Tom mentioned, an easy entry point into AWS is to take your on-premise backups and push them into AWS, and that's one of the first use cases customers tend to use. We fully support having an immutable copy in AWS as a protection against ransomware. And then we also have SaaS protection for customers who are looking at protecting workloads such as Office 365. So we talked about transform, we talked about protect, and then finally we talked about optimize. And this is more where IT analytics and data insights type products sit. And that is to help customers understand costs, complete infrastructure visualization from end to end, understand what individual applications or application groups or logical business unit costs look like. And then from on the data side of it, the ability to look at anomalous behavior or anomalous access to data, which might indicate that there's some risk of either data going missing, or a particularly bad example would be data being encrypted for a ransomware attack, something like that. The ability to actually eliminate siloed operations of different tiers of infrastructure, to have that single pane of glass, a bit of a cliched term, but a single pane of glass that looks across the estate. That single dashboard that is hugely customizable. Customers can effectively tell us what it is they want to view within their environment, and we can create custom reports that will show them that. So that is Veritas in a nutshell at a high level. That's the end of my slides. And as I said, we will be delving into, in the next sessions, a little bit more into our protection portfolio and our availability portfolio via Colin and Petter.
Perfect. Thanks, Richard, and thanks, Tom, for your input there. Well, so we've got a 10-minute break now, just for everyone to kind of.
Great, thank you very much, Simon. Morning, everybody. My name's Colin Hinks. I'm part of the UK Veritas pre-sales team, and I focus on our enterprise data protection solutions. And for the next 30 minutes, we're going to take a look at backup of data to AWS and protection of workloads in AWS. So we're going to start with backup to AWS, and like the best introduction for that topic really is this diagram. So, which is effectively an architecture, reference architecture for net backup to the cloud. We're going to work through this logically. So from the left, we're going to start with our clients. So in this case, by clients, we are talking about workloads that we want to send. So things like operating systems, applications, databases. And now we know that customers' data centers are very complicated places with a whole raft of different workloads. So Veritas's unique capability to protect in excess of 800 data sources is really attractive for customers who want to select a single vendor to manage all of their data protection needs. So we have our clients, and then we have our net backup infrastructure. In this case, we're talking about a primary server, our net backup primary server, our brains of net backup. Then we have our net backup media server, the data mover. And previously, we would have had another component, our cloud gateway, to take the deduplicated segments from the media server and send those up to AWS. But recently, we combined those capabilities into a single media server direct cloud tier component, which deduplicates the data and then sends it onto AWS. And that deduplication is a well-established capability in net backup. It's really important because it can provide data a reduction in excess of 90% to give you real tangible storage savings in AWS, but also provides network bandwidth efficiency when you're transferring that data. You will notice there are multiple red lines going from the media server up to AWS. This represents the API integration we have with AWS S3 storage classes. So this media server can send multiple data streams to different tiers simultaneously. So I could have an application's data being backed up from on-prem to one tier in AWS, and another application's data sending its data to a different tier at the same time. You'll notice on the top red line there, it says image sharing. Image sharing is where we send not only the dedupe data segments, but also the associated metadata to create a self-describing image that we can store in AWS. This means that when it comes to recovery, we don't have to have any access back to our on-prem data center in order to drive that restoration process. This is a key capability when we're talking about cloud disaster recovery and orchestration, and those are topics that Petter will be touching on a bit later on. You will notice there, so Tom was talking about the Snow family. For customers that have got large quantities of data on premises that they want to try and get into AWS, but maybe don't have the bandwidth to facilitate that effectively, we support the AWS Snow family for bulk uploads. And for customers that like AWS services, but maybe have an application with an on-prem requirement, perhaps for local data residency, we also support AWS Outposts. Now, at this point, we thought just to kind of like bring it to life, you might like to see this in action. So I have a short video demo recorded by a cloud architect colleague of mine, Tony Davids, to take us through the backup from data on-prem into AWS.
I'm Tony Davids. I'm part of the Americas Technology Practice Team as a national architect. I focus on cloud and in specific on data protection as it relates to the cloud. All right, so let's skip over to talking about MSDPC with media server deduplication cloud tiering. That gives us the ability to have block-based deduplication pool that you may be familiar with already on premises, and you can add cloud tiers to it. You can add as many as, I think, at least 64, or that might be a little crazy. I've added 3 or 4 cloud tiers, and I'll show you an instance that I'm going to demonstrate here that has, I think, 3 tiers on it. So I have one with like S3 infrequent access, and then I'll also have one tier with the worm storage on it. So this is an on-premises NetBackup primary server running NetBackup 9.1. This server is doing backups. It's in our engineering lab and doing quite a lot here. Here we have created a media server deduplication pool. It happens to be this one right here. This storage server, as we call it, has a block-based tier that's local there in the engineering lab. So it's got a pool of block storage. The primary disk pool is the media server deduplication pool, and that one up here is the MSDP DP. So deduplication pool, disk pool. So he's got about 1.7 terabytes, not too large. We scale up to a petabyte on this deduplication pool size. So then we also have the S3IA tier that's attached to that. So that's part of that same one. So we send some backups to here, and then we send it up to IA, and then we also have MSDP worm storage running up there too. So you can see the retention range that we allow there, either 1 day or up to 30-day retention. When that, you set that when you create the pool itself. This tier has been added, and I'll drill into it just to show you how the cloud recovery server that we've been talking about and the image sharing works. Looking at the disk pool, the bucket name in AWS is Rob NDU83 worm, and then the volume name, which is just the subfolder in the bucket. So you can see the parameters here. But what I'm going to show you is, so this is the on-premise primary server. Here is the cloud recovery server. I deployed this from the marketplace. You can provide that bucket name and that volume name, and it'll automatically deploy it and set up the cloud storage server for you, pointing at that exact same bucket and subfolder that that on-premises server was pointing to. And you can see it says MSDP for image sharing. That's a little different. So this is a read-only look at it. The on-premises server controls it. This is going to allow you to do disaster recovery and reuse of the data within the cloud. This has been set up, and if we go over and look at that disk pool that's part of it, you'll see here also that the bucket name is that same name. So we're pointing at the same bucket. This server I usually just leave it shut down and I only spin it up when I need it or when I'm going to demonstrate things. You could spin it up just in time from the marketplace, put in that information of the bucket and the volume in the CloudFormation template from the marketplace, and it'll automatically spin it up. Or you can do like I have done, and I've got it already running, and I can just shut it down when I don't need it. So it's only using a small amount of storage, maybe 500 gig or less, I forgot how much, maybe a terabyte, but you can use a very small amount of storage, so it can be shut down. You're not paying for compute costs. You just got minor amount of storage there for the application and the operating system drive. The thing that you'll see here on a cloud recovery server with our image sharing is on this disk pool, there'll be the 3 little vertical dots. You'll be able to hit this and you can say fast import. So those of you also familiar with NetBackup will know this seems kind of like our days where you take tapes in the old days and send them off site, and then you could take and import them in the other side. We do the same thing here. We import them, but the good news is the metadata is included with the backup data. So self-described in our case, because we know how it's described. Importing this information is so fast. Not like the tape days. I can click on import and say yes, and in 1 second, the job will probably run for 4 or 5 seconds, but the import actually takes 1 second. And I could have clicked on 100 of these and imported them all at once. In that case, if I go over to the activity monitor and take a look, you'll see it tells you in the overview, this is the backup image for those who are familiar with NetBackup. It's the client name and then the Unix time format. So it tells you how fast it's done. So in this case, the whole job ran in 4 seconds. So less than 1 second of it was the import. And the important part is now when I go over here, since it was a VMware image, and if I go over here and take a look at the recovery points, I will now see those recovery points in my console here. So I'm able to do recoveries here. And the great thing is if you've implemented VMC, for instance, and you have that set up, you could have the credentials set up in here for VMware and actually do the restore the virtual machine here. You could do a granular file recovery because we did a granular file in there. You could recover it there, or you could even recover back to an on-premises VMware environment if you have this set up in a hybrid mode where you have a continuous kind of 10.x.x network. And you can also take that VMDK backup and you can click on convert and do it. So this is sort of the manual method of it. We have Veritas, or it's now NetBackup Resiliency Platform. So the resiliency platform would orchestrate all of this for you. You just set it up so the backups are going to the cloud, and you have this all set up so it would be fully automated so that you could click a button and you might want to restore a whole application, and you could group that together in a resiliency group, and you can have virtual business services as it's described or called in there. So you can bring things up in the right order. You bring up the database, you convert the database, the Microsoft SQL database, for instance, then you convert the web server and you convert the app server and you bring those up in the right sequence. And you can do it in a test environment up on AWS in a test network, try it out. You can do it as a production switch for it. So it'll control all of that, shut down the machines on premises, bring up the ones in the cloud. You have risk reports to tell you, like, do I have recent enough backups in here to meet my SLA? So the resiliency platform adds a ton of orchestration, risk mitigation, and reporting for you there, and the ability to do rehearsals also there.
Okay, so we saw there backup to AWS from on-prem, and then Tony took us through the conversion and recovery of one of those self-describing backups in the cloud. The next topic we're going to have a look at is backup mutability. And the reason that we're talking about backup mutability is because security is a really important topic. In fact, it's front and top of mind for most customers. Now, we follow the NIST framework that defines strategies for the layered approach to our security. And the Veritas portfolio covers a lot of these areas. We're going to focus on the core competencies that are relevant for today's topic. And those core competencies are protect, detect, and recover. Now, I appreciate this is a busy slide. There's a lot of detail on here. You're going to get copies of these to read at your leisure. For now, the piece that we really want to focus on is on this protect column, and that is storage lockdown. And by storage lockdown, in this sense, we are talking about being able to store immutable copies of backups. This is something that most customers want to achieve now in the sphere of ransomware protection, and that's why in NetBackup 9.1 we introduced support for AWS Object Lock, and we delivered this integration on top of an already supported feature that we had, which is support for AWS Private Link. This allows customers to connect their on-prem NetBackup infrastructure to AWS without the data ever leaving the AWS network. And this is critical because this further reduces the attack surface on your data. Now, I mentioned earlier on that our backups to AWS are deduplicated through the direct cloud tiering media server. So we had to take full advantage of the AWS APIs in order to provide the really low granular level control of the dedupe objects, which is really critical when you're storing deduplicated data segments within the cloud. So at this point, we're going to get Tony to take you through a demonstration of the use of AWS Object Lock with NetBackup.
Let's take a look at worm capability. We start off with our storage server. We've got the on-premises block pool. We added to it cloud tier, as I talked about before. We actually have 3 tiers on it. And one of those tiers now on AWS, the object lock tier. So in this case here, we're in a bucket called Rob NBU 83-worm. The volume name is this, so you'll just see the subfolder there. Just to take a look at where that is in my AWS console, I've gone to S3, and in the storage, you see that bucket. This bucket, as you can see, the properties of it. If you're familiar with object locking, the first thing that's required is it has to turn on bucket version, and it tells you that. It says bucket versioning can't be suspended because object locking is enabled. So if we scroll down to the other properties of it, you see object lock is enabled on this bucket. So everything within this bucket, these different objects, and here you can see what we call the volume, which is that very first subfolder within the bucket. That's here. You could have maybe multiple cloud tiers writing to that same bucket if you wanted to. When you configure it, you can choose your tier, and then you can also choose, sort of the redundancy of it. Most of the time, I would say definitely you wouldn't choose the 1 zone, because that's 3 copies within the same availability zone or the same data center. But I was thinking about it earlier in my comments about data reuse. Maybe that is a good case for data reuse, because it's something you already have another copy elsewhere. You want to keep the cost down, but you're going to use those copies for restores and doing data analysis maybe. Here we have the actual bucket up there, and it's set up for object lock. Honestly, there's one little extra step that you do to set up that bucket beforehand, but you could have it set up and running. I did it with my colleagues in less than like 10 minutes to have this actual tier set up. You decide on what retentions are going to be allowed within that pool. And that's important in a ransomware world too, where if they could somehow change the retention on your backups and make it really short. We did make it very short here, but if you made it very short, you could restrict it to say there should be no, the minimum lock duration has to be at least 30 days and the maximum maybe 1 year or whatever it may be, so that the ransomware attack couldn't move your retentions down to something really short, so everything expired on you, for instance. So here in this case, we're writing it up to this bucket. After that, there's not much exciting about it in that sense, because it behaves just like any other storage unit, except it's got the write lock on it, or the object locking for it. So you can send backups to it. You can send them directly to it if you want to. And one thing I didn't mention, we talked about a lot about hybrid environment, where you've got your on-premises environment and you're writing your backups to the cloud. We have lots of customers who are using this in the cloud. And honestly, we recommend that they use either S3 standard or S3 IA as their primary backup target, because once you're in the cloud, the performance and latency is so good from AWS that you can use that and restore a recovery time objectives that you see running on premises with block storage, but at a much reduced cost. So instead of writing to that EBS storage in a deduplicated pool, use the object storage, which is even at the S3 standard level is 78% savings over the elastic block storage in an SSD format. So use that as your primary tier if you're backing up in the cloud and you're using MSDPC there. It's a much better price savings. And honestly too, then you could jump all the way down to, $12.50 a month kind of average price per terabyte for the S3 standard infrequent access, and use that if you're not doing too many restores or too much duplication. In the case of the worm technology, it was critical and it was important, and AWS helped us first to support them in this worm capability, because MSDP technology is if we just in the old days sense, like we back something up, we had a backup image, we use the native tar format for our images, so our backward compatibility is really back to forever ago in our early versions, if you have an old tape or an old backup. But when you write that to the cloud, that's going to have a retention. So if you did the object lock at the bucket level, that would work fine for that. But with deduplication, you're breaking it down so that the shared data between all of those backups is data segments that are shared across all those backups. They're put up there in small chunks. So each time you write a new backup that shares that segment, you've got to extend that lock. So the locking at the object level was critical for us to be able to use object locking and deduplication technology together to make it work right and be safe and secure for you.
Okay, so we're going to get on to the last section now in this presentation. We're going to look at backup of data in AWS. And our entry point to this is another architecture slide, right? And you probably think, well, this is the same one as before. It is very similar, and that is by design. And this is to really illustrate that we share the same values and capabilities of protection of data in the cloud as we do on-prem. So if you look at that large arrow in the middle there, you can see our customers can enjoy pretty much the same capability as they in the cloud as they do on premises. So we have the ability to take application-aware backups and recovery, and those recoveries can be at a very granular level, including right down to individual granular file level recovery. We can take cloud-native snapshots, including incremental snapshots, and we have lots of flexibility around our policy creation, including the ability to create intelligent groups. You'll notice there's an arrow there between the two AWS regions. It says Auto Image Replication, or AIR. This is a well-established net backup capability we've had on-prem for over a decade, where customers can replicate backups from one on-prem primary data center to a disaster recovery data center and have those backups immediately available for recovery in the target domain. We've extended that capability to for replication of backups between AWS regions. Right, so at this point, we're going to have a final trip over to Tony to give us a demonstration of protection of workloads in AWS.
Within the cloud, we have the ability to take a look at and discover all of the assets in the cloud, virtual machines, in this case, EC2 instances. We can also discover RDS and protect those. So we can take snapshots of those for you. So what's the advantage to doing this through NetBackup? So those of you with a hybrid environment, your assets on premises, and you may have things running now in the cloud, you have the ability to protect those both the same way and have a consistent interface for audit and a consistent interface and report on it all there. So the first thing that we would do, set up the Cloud Point. That's the ability to do the cloud native snapshots within the cloud. You can deploy that from the marketplace. Also have our Cloud Point servers, which help do the automation and interface to cloud service provider like AWS in order to be able to orchestrate those snapshots. So we can do snapshots in a lot of different ways. Crash consistent. We can do file system consistent snapshots and provide you with granular file recovery with that. We also support 3 different database applications running within those EC2 instances. So you're able to do snapshots of EC2 instance with an application consistent snapshot of Microsoft SQL Server, Oracle, and MongoDB running within those EC2 instances. You can also do restores at the database instance level. Within the applications tab here, we'll have those ones that are discovered. In this case, running on AWS, we've configured and discovered Microsoft SQL Server instance running in an EC2 instance. And we have RDS instances from 2 different accounts actually here. The native account that I'm in, the 113 account, and then product management account 069 over here. We also have the capability of leveraging and utilizing the capabilities that AWS provides us. We can orchestrate that snapshot, and then we can also say replicate it to another region. We can take the snapshot, replicate it to another region. We also support cross-account replication. So we can take a snapshot within the 113 account. If I jump over here to my protection plans, I've kind of got protection plans for all of the different capabilities. So cross-account replication that I mentioned. So I take a snapshot in 113, send it over to 069. That's the prefix of those accounts. We can do Microsoft SQL Server database level snapshots. You can snapshot the entire EC2 instance, and that's an application consistent snapshot with the database, and restore that either in the same place or in a different place, different availability zone, or maybe even different region if you replicated it to another region. Then you can take a snapshot at the Microsoft SQL Server instance level. So then you can also restore that to the same machine or an alternate host if you want to. So this is a database level protection plan that's going on. Here's a Microsoft SQL Server instance level snapshot that's going on. Of course, I got a protection plan that's snapshotting the relational database service instances here also. And this one is actually doing it in that other region actually. Then we have other things. You can do snapshots at the volume level if you want. This one's a replication from 113 and then going over to US East. Then we have granular file recovery. The great thing we do is we index the snapshots and you can do granular file recovery. So if I jump over here to a machine where we're doing that in AWS and I take a look at, this happens to be our SQL Server. So we're doing an application consistent snapshots, and we've got 2 protection plans here. One is replicating and one is doing granular file recovery. So if I go now and look at the recovery points here, I can see there's different copies based on the time of day they're doing them in those 2 different protection plans. So this one's the replication one. You can see the snapshot in US East 1, and then you can see the replicated snapshot over in US East 2. So I can recover from those, and I said restore the virtual machine. We'll restore it in the same location. Rollback restore on top of itself, and then here is the granular file recovery. So if I click on granular file recovery for that machine, I can go through now and either search up here or browse through the file systems here. In this case, the C and D drives on that Microsoft SQL Server. If I go in here and look for something, I can look for the MDF files, and and you can see the demo database I have and the master model and TempDB, the standard ones in there. So I could grab, one of these and actually do a restore of just the database file itself if I want in a granular file recovery. And I could add other files in here. And then we have a very nice wizard that you can choose alternate hosts if you want to. In this case, I don't have any alternate Microsoft SQL Server hosts or hosts that are configured for granular file recovery, but I could restore to an alternate machine if I wanted to. I also have restoring to the original or different directories. And with the role-based access control, all of these are actually very granularly controlled so that you could say, well, don't allow them to restore to an alternate host, or don't allow them to restore to the original directory, only different, or vice versa. So all of that in our role-based access control is granularly covered, so that when you enable someone for that self-service, they have only the capabilities that your company wants to allow them to do. So this is just a review of things, and it's as simple as kick it off here. And same here, I've got the other copy here, so I can do the restore virtual machines, rollback restore, all of those different options. You can see your copies, and in this case, as I showed, you could restore from either copy. With application protection over here, for instance, if I wanted to do a restore, so this is the user database that we're taking snapshots of. You can see here that being protected, and it's the demo DB that we're taking snapshots of. But you can jump over here to the recovery points. You see your recovery points, and we have the ability to restore it to the same machine, which is the original location. So it'll restore the database back to it, or an alternate location. In the case of the alternate location, we can choose another Microsoft SQL Server that's set up. We also allow you to restore it either with recovery or no recovery. So in case you have tail logs that you might want to apply, you can bring it up with no recovery and then apply those. And this makes it easy, for a non-DBA person to be able to do these kind of restores. You don't have to be an expert within SQL Server to do so. This one's nice too, with the alternate location recovery too, is being able to, for a developer or someone in DevOps that wants to do a quick restore of that machine, do some tests, or test out some of their code with the latest data that's available out there. Another thing that we added was intelligent groups here. The intelligent groups makes a nice way so that you have hands-off capability of protecting things that you want to protect. If any of you are familiar with our VMware intelligent policies, Oracle intelligent policies, or SQL intelligent policies, are very same concept. So it's a rule-based group here that will select the things that you want to protect automatically as they come online. In this case, if I drill into RDS instances, this intelligent group, I can look at the assets here, and it shows me the ones that are selected in this case. First off, you narrow it down. You can pick the account that it's in, you can pick the region that it's in, and then actually the asset type, whether it's a virtual machine, an EC2 instance, or one of the applications we discover, either RDS or one of the ones that we've discovered, Microsoft SQL, Oracle, or MongoDB, for instance. Here, it shows me the number of assets that it's selected here. When I set up this intelligent group, I chose applications, and I said include all assets this type within that account of the application type. That's what gets discovered here. And then this preview button, when you're editing, it does the same thing from there. It shows you which things are included in that. What I can do from here is I can add, in this case, I can see that this intelligent group has been added to this protection policy. So every day, between 8 and 6, it's going to run snapshot backups of this RDS instance or any other RDS instances that get added to that 113 account will automatically get protected. They'll get backed up daily, retention, all that stuff. You can set it within there. So you can narrow it down by account and by region. The big thing is tags. So this one I have set up with the tag called owner with a value of my name in it, and then it shows you all of the things that are there. In this case, I'm selecting virtual machines from this account and from this region. So it's automatically selected all of these. So if we edit it, you can see there's a rule down here that says tag owner. This shows me all the tags that happen to be available within the scope of the account 113 and in that that particular region, US East 1. So all of the different tags that are there show up here. So you can see them, you can choose them, and you can have a rule against it. So you can add a condition, you can even have a subquery on that particular condition. Every time a virtual machine in that account and in that region gets added with an owner field equal to my name, it'll get selected and it'll get protected if you add it to a protection plan. So automatic ability to protect things, which is great. In a cloud environment, things are going to come and go. So this makes it zero maintenance for you to do that protection. In here, I'm looking back on the backups a week ago. I had already converted one of them, but it gives you the AMI. You can click on this and copy it. And I could jump over now to the AWS console and just launch this AMI and I have an EC2 instance running. Or you can have all of that automated for you, so you don't even have to do that. Just one button click and it fires it up either in a rehearsal or in a production takeover if you wanted to do it that way. Whenever you hear us talking about cloud recovery server or image sharing, this is some of the cool functionality that you can get here. Being able to convert this, and also the cloud native capability that I was talking about, the orchestrating the snapshots. That's also included if you're using NetBackup Platform Complete Edition, essentially our capacity licensing. All of that's included in it now. So anything you're protecting with NetBackup, you can also orchestrate with Resiliency Platform.
Okay, that just about wraps up this session. I hope you found it useful. I'm going to be around until the end to answer any questions that come up on the chat. And at this point, I think I'm handing over to Petter.
Petter. Yeah, brilliant. Thanks very much, Colin. Over to
Thanks,
you,
Colin.
Petter, if you can.
So, yeah, and that actually leads nicely into the next section, which essentially is providing availability and disaster recovery to and in AWS. And the first part of that, we're going to do show you exactly what Tony talked about. In other words, the orchestration of the recovery with the resiliency platform, whether it's for migration purposes or disaster recovery purposes. So my name is Petter Svam. I'm the availability solution lead. I cover the international region, including EMEA and APJ. I'm glad to be here to talk to you about this stuff today. So let's dig into it. So when we're looking at this, we'll start from the first use case, which essentially is the backup process or backing up of the data on-prem, where Colin started with this aspect, writing the data out into S3 and through the MSDBC integration securely with a self-describing image, and then leveraging the cloud recovery server function, which is essentially is a contained media master server that can be permanently running in your cloud environment, or you can spin it up dynamically at the time of recovery. Now you could do that manually, obviously, but if you're doing it manually, then you're driving an operation. If you wanted to have a kind of more of a mass migration or have to address the requirement to recover quickly for many parallel workloads, then it's good to have an orchestration capability that allow you to take this one step further. So using that image sharing function, we can introduce the resiliency platform. Now, the resiliency platform are a set of virtual appliances that get deployed into the VMware environment, as well as into your VCP environment. They're from in Amazon, obviously, using the marketplace and machine images. Now, we provide the orchestration and you run through the discovery process of what you have in VMware, as well as what NetBackup has actually backed up already. So that's just by connecting to your vCenter server, running through the discovery, connecting to your NetBackup solution and running through the discovery there. We deploy the resiliency platform components in the public cloud, and we tie these two resiliency platform instances to each other. Essentially, there are a couple of different components for the resiliency platform. There's the resiliency manager, which holds all the orchestration, management, and the UI. and then the infrastructure manager, which holds all the connections to and credentials to manage the various assets, vCenter, vSphere, NetBackup, and your subscriptions and credentials within the VPC. The next step, of course, is to actually manage this process of utilizing the data that sits in S3, which is essentially the backup image, to drive the recovery process. And by that, we dynamically provision the cloud recovery server. If it's already there, we can reuse it, but if it needs to be, we dynamically provision it. We import the image and we prepare it for recovery. And then we can provision the required compute and storage resources, whether that's for non-production rehearsal, could be used for dev and test purposes, could be used for just a DR rehearsal process, or whether it's to actually recover the workload, again, just in time provisioning of the virtual machines and the volumes that you're going to use. So let's see how that works. And we're going to divide this into two parts. We'll talk about how we set up the environment, and then how we will actually use it to run the recovery. So this is the resiliency platform. You see that it's a separate UI, but it's connected to the NetBackup UI, and there's a cross-launch capability. So I'll go and look at my unmanaged components first. And here I see I have a VM that's prepared for recovery. I know it's being backed up already, so I can use it. I'm going to select a service level objective. Essentially, that's managing it against an SLA for recovery point and recovery time. And as I create this resiliency group for this one VM, I'm also going to select the type of storage I'm going to use in the cloud. I'm going to select the type of instance I'm going to use in the cloud. And I'm going to tie it to the security groups, both for the actual DR use case, as well as for the rehearsal use case. This, as you see, is very flexible on discovering the requisite security groups and networks in the cloud as needed. I can also apply IP customization as part of this process. So whether I want to leverage the paired networks, in other words, the networks that are paired from on-premise to cloud, whether I want to use a specific IP, I can override that paired network setting as part of it. Then I give this resiliency group a name. And once I've done that, it'll run through the configuration process to actually provide me with this capability and configure it in the background. Now I can actually click to view the progress of that if I wanted to. And you'll see exactly how we do that in a minute. But you see that it's in the process of configuring, so it's preparing. Now you see how we manage assets or resiliency groups holistically. You see the details of the workloads that we're protecting. Yeah, okay, we're going to look at the configuration itself. So we have the capability to take the higher ordered steps and to manage the detailed steps under the covers.
Yeah, that's what will happen. Okay, where we don't have it.
Right. So you can always expand those detailed steps to see exactly which step is currently being run. Let me just click here and make sure that we continue the video. And that's really useful because it allows us to also see the timings of each step, as well as if something does go wrong, why it went wrong. We'll see the error code, you'll be able to trace it, etc. So we're just going to let this process complete with all of the various requirements in place. And here we go, it's done. So that takes a few minutes. Now we're going to go back into the resiliency group, and we're now online and we're ready to recover. You'll see that we see the point in time images. This is all tied back to NetBackup. So when the backup was performed in our primary data center, as well as when it was made ready. You also see the various components both in terms of the network, the compute, the storage we're using, the backups, as well as the customized workflows if we had any. You also see that on the left-hand side, or sorry, on the right-hand side here, the core operations we're going to be able to drive: start, stop, restore, rehearse, as well as clean up from rehearsal, or if you wanted to do an actual recovery, a clear outage after a disaster. So let's drive a recovery now from this this perspective. So we're going to run a restore. And essentially here I get a choice whether I want to use the latest or whether I want to pick from a time range. Now, picking from a time range could be very relevant if you're addressing a requirement to recover from a ransomware attack. Again, you see this higher order orchestration that we have embedded for all the workflows we run. These higher ordered steps that actually consist of multiple sub-steps, and of course, again, which you can expand. Now, one key thing I want to note here, and this is very important when you look at the recovery time and the tolerance for the recovery time, is that it does take a little bit of time to import the image, convert it, and then recover it. That, of course, is because we're reading the data from S3, and we're then converting it, then writing it back to EBS, and then doing the post component, post orchestration components. We see already that we have the VRP, the InfoScale image coming up in the NetBackup image coming up in AWS, and we'll be able to use that effectively as soon as the conversion process is completed. And here you also see what I talked about a little bit. So it's important to leverage the right type of recovery process to address the right type of recovery time objective, right? This can be useful for those workflows where you have tolerance for a little bit of recovery time. If your tolerance is lower, there are other technologies such as the VRP continuous data protection capability or replication functionality, or the InfoScale components, which we'll talk about later. So the recovery process is complete. Now we're connecting the VM to the networks. We're applying the changes to the virtual machines, and we're registering it with the AWS. And there we see the virtual machine is up and running inside of AWS, completed end-to-end from a resiliency perspective. And then the last two steps is really to start the machine, do any post start machine operations like updating DNS, making sure the routes are up to date so that you can connect to that virtual machine from wherever you're connecting it to, or to it. Right. I'll just let you see that it finishes. So all done. Now, the next step is that we can, of course, leverage this capability using NetBackup, using the NetBackup images written down through MSDPC. But the resiliency platform also has the capability to actually replicate data directly to and into AWS. Now, in that case, we don't need to convert the images. Essentially, as part of that process, we discover the VM configuration on-prem, and you select the instance configuration in Amazon and the type of storage that you want to use, whether you want to write directly to S3, whether you want to write directly to EBS. You can write directly to S3, but then at the time of recovery, you're going to have to convert it to EBS. So that's the key. It does give you the capability to now do non-production rehearsals, dynamically allocating both storage and compute and networks, and just-in-time recovery for production. The key difference between this technology and the NetBackup integration is that now I can also change the direction of replication and replicate back to on-prem. So again, if I'm using this as part of a migration process, something goes wrong with migration, I still have the ability to just fail my workload back to on-prem. Or if I'm using in a DR scenario, I have the ability to use the cloud as a disaster recovery platform, and then still, once my on-prem is back online, I can fail back to on-prem. I could do both though. This is the other key, right? I can have multiple workloads that have multiple different recovery points using both NetBackup as well as the data mover. Or I could have workloads that are only using the data mover and workloads that are only using the NetBackup images for recovery, addressing different SLAs for recovery points and recovery times as needed. All right, now this does address some of the disaster recovery requirements, but there you could have some critical workloads that go beyond this, right, with no data loss requirements, as well as recovery sort of measured in seconds or minutes. And for that purpose, we've introduced the capability to leverage InfoScale in AWS. This essentially is a capability to build out a high availability and disaster recovery architecture, both within a zone, where you're either using our disk agent to attach and detach the underlying EBS volumes, or using our flexible storage sharing components to help you mirror data between hosts within the cluster. And this can also be stretched between availability zones. So you can actually have the ability to mirror data between availability zones using our flexible storage sharing. But you could also use our storage replication capability that is embedded within InfoScale, block level replication, both for Windows and Linux, that allow you to provide you with a synchronous replication in this scenario. Ensuring that you can recover in the case of a failure of a zone or infrastructure within a zone. Again, if you need to go beyond the scope of an availability zone, you have the ability to tie region to region together, utilizing the asynchronous replication. Now, in this scenario, you could have continued to use our replication technology, the embedded volume replicator within InfoScale, but we also support you using application level replication like DataGuard for Oracle or HANA system replication for HANA DB, the Postgres replication capability that's transactional for DB2 or same thing, or Sybase, et cetera. It's a lot of different agent functionality and capability that allow you to do this granularly. And you can manage multiples, right? So you have multiple different components in different scenarios if needed. This gives you the capability to have granular recovery for individual applications and workloads, even multi-tiered business services, as well as an entire site. So if I think about this, there's some key new capabilities that we want to talk about. One is the capability to allow you to utilize Volume Replicator to help you to migrate from one scenario to the other. In order to do this effectively, we've introduced the capability for you to deploy in the cloud using CloudFormation templates. These are actually quite flexible, including the capability to have a single node up to 8 node clusters. And while we can support larger clusters, that hasn't been programmed into the CloudFormation template. Most customers, though, tend to use automation engines such as Terraform or Ansible or Puppet or Chef to help them establish and automate the process of configuration in the cloud, whether that's allowing them to actually manage the storage, the instance, the OS, and any clustering components, network components, and application components in a single go, significantly reducing the time it takes to provision components in the cloud. Once that's established, you can leverage Volume Replicator to easily migrate data and the application configuration from on-premise into the cloud. So you can also use then to test and validate non-disruptively, because we can take an in-band controlled snapshot for the workload on-prem, but actually provide that snapshot in Amazon. So you can give your application owners and developers the ability to test and validate their application in the cloud non-disruptively without taking down any workload on-prem. And we've built in a wizard and a workflow for you to allow you to manage this. This scenario can of course be used in a migration, but it can also be used to allow you to provide or use the cloud as a disaster recovery target for critical workloads. So it can be ready, and you can reverse the direction of replication and fail back to on-premise as well. Now, one of the key aspects that we talked a little bit about is the flexible storage sharing that allows you to provide mirror data between availability zones. And essentially what this does is it takes the local storage that's allocated to an instance and share that storage within the private network between instances where you're running InfoScale. That way you get mirrored storage or stripped and mirrored storage that's immediately available on multiple nodes in different availability zones. This can be scaled out, so it doesn't have to be just 2 nodes as is illustrated in this example. It can be up to 16 nodes that we've tested, but we actually support this up to more nodes as needed. Just let us know what the workload is and how you need to be able to support it. Now, in order to illustrate exactly how this is done, let me run through an example and show you how easy it really is. Now, this is a little bit of an older example, but the fundamentals are the same. And you'll see what I mean in a minute. So we allocate sort of the private networks, and we've done a lot of work to make sure that we can run the IOs across those private networks in an effective way. And we allocate some storage that we're going to use both for the block device, the root device, as well as for our data devices. We're going to fire that first instance up and have a quick look once that instance is ready. And it should be ready now. So we're going to see that we've already installed the cluster. So we installed InfoScale completely. It's running, but it's inactive because there's no second node, right? So there's no neighboring cluster node to connect to. But the networks have also been configured. That's the LLT stat. In this case, we've configured dual redundant networks or redundant private networks to make sure that we can tolerate failures of those networks. Today, you don't have to use multiple private networks if you don't want to. We can tolerate using a single private network if needed. Now we fire up the second one, and we see that immediately the cluster is now active. One is configured as primary, and the other one's configured as secondary. We also see that the service groups that we've configured, which is only for storage, are up and running. So we see the cluster volume manager service group up and running on both nodes. And we see that the networks that are connecting these 2 nodes are up and running as well. So let's have a look at the storage that we have available on each node. And we see that we have 3 disks that are visible to me that I can use. I'm going to have a quick look at on the other node. That should be the same. I should see 3 disks there as well. Now, in order to use these disks and to be able to share them between nodes, what I'm going to do is I'm going to configure one of them for setup on each node, and I'm going to export them to the neighboring node in the cluster. So I'll have a quick look. Okay, I see one is now online on each of the nodes. And now I'm going to export the disk so that it's going to be visible to the neighboring node in the cluster. And all of a sudden, I see 4 disks from each node, one exported and one remote. I'm going to take these 2 disks and I'm going to join them into a disk group. That'll essentially, by default, because of the configuration settings that we've already applied, will allow me to use flexible storage sharing. And any volumes I create here will be mirrored at the host level. So I've already prepared for that, right? I can apply settings like tuning and tweaking the block sizes, as well as in terms of what kind of IO I expect to get. But for these purposes, I'm just going to mirror my data across. And I see immediately that I get that host-based mirror. I'm going to put a file system on top of this, so we can use this for our little experiment here. And then I'm going to mount it. I'm going to use the CFS commands to actually create that resource within the cluster and allow the cluster to mount the file system. Once it's up and running, I see it both on both nodes essentially. So I'm going to run a df-k on both nodes, and I see the AWS FSS file system there, and it's also available and visible to me in the cluster and ready for me to use. So let's use it. I'm going to write to it from one node, hello from node 1, and then I'll concatenate that file or cat that file from the other node so that I see it, and I'm going to append it using adding from node 2, and have a quick look here. The file has been updated, and you see that it says has been appended appropriately. This essentially is the key capability, very, very simply illustrated. But obviously, you want to leverage this capability and this functionality for a wider use case, right? So in order to do that, we had to improve our functionality within the cluster to make sure that it worked properly within AWS. So we've introduced new agents into our application service groups that you can leverage for applications and services that run inside of Amazon. These are for managing IPs, Route 53 and DNS, as well as the EBS volume resource. And the service group purely is the capability to help you manage the availability of the application. So the AWS IP allows you to manage the different private, elastic, and overlay IP functions within AWS. You can, and this is what we need to do to have available in order to do things like update routes and update virtual IPs for resources as they fail over from one node to another, in particularly when they fail over between availability zones or between regions. For solutions within availability zones, you can also use the load balancer, and that's also now being used successfully between availability zones as well. The other key thing is we want to make sure that we can add, update, and delete DNS records to Route 53 and as well, and then refresh the routes accordingly. You can use the AWS Route 53 service, but you can also do this with a manually configured DNS service. So if you stand up an instance using a Linux DNS or an Active Directory service, you can do that. You can use that as well. And then finally, the attach and detach of storage resources using the EBS volume agent. As I mentioned, we can use the EBS volume agents to help you attach and detach storage, but it takes time because we're communicating with the underlying APIs, and that means that failover time is going to be impacted. With flexible storage sharing, we do not use the EBS volume because the volumes that we create, they're always attached to the local node, and all we do is move the mount point or ensure the mount point is available parallel on both nodes. So all we really need to do is move the workload, stop or start the actual application. There's one other key dependency here, and that is the AWS CLI package that we use to manage the roles and authenticate and authorize the cluster to an InfoScale to perform the operations that we need to perform against the IP and network components, the DNS, as well as the volume components. Now, we built this capability to work with all of the various application agents that we already have available. Right? So you can take any of the capability that we've pre-built, as well as generic application components, to allow you to build out this functionality to deliver fast failover between availability zones within AWS. So let's have a look at what this actually looks like for an Oracle database. So in this configuration, I actually have two node clusters, and each node is in a separate zone, and each cluster is in a separate region. And they're actually configured with replication already as well. So we'll see how that is actually managed and impacted. But the initial demo here is just going to be a fast failover of Oracle between two availability zones. So I'm going to have a quick look at my my cluster service group configuration. So I see my Oracle app there is online on 109. That's where I'm currently connected. I'm also going to check the Veritas cluster server configuration. Now, this may be a little bit technical for those of you who are not familiar. Essentially, it's just our cluster configuration file that allows you to see. The reason I'm doing that is because I want to show you the overlay IP resource that I'm using to connect to the database through the listener, and the replication IP address and the mount point for Oracle. So the mount point here is the CFS mount point, similar to the mount point that we used or showed you previously in the FSS demo. And then we have the replication IP, which is the log owner rep there. That's also an overlay IP. It needs to be changed as part of the failover between zones, as well as in the failover between regions, right? So updating both the routes for that IP and DNS for those instances. All that is then fully automatic. And just to show you that, here you see the current routing table that we have up and running. So let's do just a state and verify Oracle is up and running. So here you see the Oracle processes for PMON are up and running. You see the listeners up and running as well. We see that the replication is up and running. It's also replicating connected. It's currently asynchronous, but it's up there. And then we're going to check the mount point for the Oracle data. It's in both my 109 and in my 231. That's the two nodes that actually are in the same region, but in two different availability zones. So let's do what is that disaster would actually look like. Let's stop the instance, simulating that the hypervisor failed, right? So the instance is gone and I lost my connection to 109. What happens now? So now immediately the cluster is going to notice that I've lost connection, and it's going to start to recover the application on the second node within that same region. And it's all online again. So it takes about 20 seconds to do that recovery. Now, in this case, to be honest, that's extremely fast, right? But there's not a ton of recovery happening within Oracle. If there was recovery happening within Oracle, that would come on top of this. In addition, we made sure that we moved the replication IP. We updated the routes. And here you see the routing table again. So we're still replicating, connected, and so that's a dependent service that comes along. Now, as I said, this is not just a local cluster, so we're not just doing failover locally. We're doing failovers regionally. We're providing you with the capability to do failovers regionally as well. So let's see how that works. So same cluster again. Just to provoke our own capability a little further, we have the failed node. We haven't fixed that yet. What we're going to do essentially is we're going to fail the second node in that region. So 231, right? So we see it's online. We see it's replicating, we're going to just make sure everything's good. And it is. And so let's go and stop that instance as well. Now, InfoScale can actually provide you with automatic as well as automated recovery between regions. This is a configuration setting that is viable to you. It depends on the workload, the type of recovery. Now, in many cases, customers will choose to have an automated recovery when they're recovering between regions, while more and more customers are actually choosing to use a fully automatic recovery between regions. So there's a little bit of a preference, right? Whether you want to run a command to recover or click a button. And in this case, we're using the command line to illustrate the example, but you can do this from the UI, both the InfoScale UI as well as from other UIs where we have integration capability and API capability today. So you have that functionality available to you. So essentially what it'll do is we'll just, in this example, we're just going to start the service and on one of the nodes in our remote system, and it'll come up, bringing online the data, the various dependent resources, services, including the replication, as well as the database itself. And you see that the state on the 231 is actually online stopping because we lost connection with that node. We don't actually know what the state is. Once we fire it back up, we'll be able to clean up, right? The Oracle app comes up, and both the Oracle database is ready to be used, as is the listener. So we're able to access our database again. Now, for this to work properly and for us to have all the connections available, we need to update the routing tables and the DNS entries. And that might be tied back into TNS clients as well, right? So we have a full-fledged service resiliency here. Okay, now we see that the state is faulted, but we do see that replication is enabled, and we're ready to replicate. So the second stage of this type of capability is to actually derive the recovery of our primary sites, making sure that I can be ready to fail back to on-prem, right? So for that purpose, now let's just start these two instances again, simulating that our Amazon friends have done their work and brought up the services in our primary region, and that these instances come back up alive. The key thing here is I'm going to need to connect to them, and I'm going to need to reconnect replication and make sure that replication flows in the right direction and resync. That, of course, is all automated, so it's a few commands or a few clicks in the UI to ensure that you can do that once the cluster comes back online and reconnects. So here we go. We're back online, and we have a good connection. Now we see we have a primary configuration. In other words, the failed cluster still thinks it's the primary, but we know that it's the secondary cluster that is actually the primary. So we're just gonna do a forced resync and make sure that we do that as effectively as possible to connect the two. So there's a failed back sync to resolve the primary status, and that's it. We'll resync, and it takes a little bit of time, obviously, depending on the amount of data, the amount of downtime you had. But then you'll be ready to do a failback if need be. And here we go. We're up to date, consistent, replicating, and we're completed. So now we could run a failback to our old primary and run my workload from that perspective if I wanted to. So before I sort of leave this, I want to show you two other key things. So one key aspect is that you can leverage the different types of storage to help you accelerate the performance of an application in AWS. You can do that for a single instance workload or in a cluster. That doesn't really matter. So if you have block storage, EBS, ST1 block storage, you can supplement that with GP3 or IO2 flash storage to help you improve the performance. This can be used through our Smart I/O technology, which allows you to cache reads or write requests within a cluster, read requests in standalone or within a cluster to help you improve application performance. We've also embedded analytical tools to allow you to actually assess how big the cache should be, depending on the workload and the I/O types, as well as what the impact is going to be on your application performance. This is also a good way of balancing cost, right? Instead of going all in and buying only high performant flash, you can mix and match your EBS volumes with the right type of storage class, support the right type of storage class. And extending this a little bit further, we also have the capability within the block layer to actually write data between different the different block layers, but also to object storage, also to S3. This is based on file type, age, access pattern, as well as location. And it allows you to seamlessly tier that data without the knowledge of the application all the way down to S3. This is truly useful for an application like Splunk or some other log gathering or transactional gathering application where you're writing immediately to a highly performant storage layer, but then after a week or a month or within whatever time frame you have, you want to tier down to a lower tier of storage. But you still want to retain the ability to search that data, and so you keep your indexes seamlessly on high performant data. Holistically, all these capabilities allow you to actually ensure that Veritas can support your journey to cloud, giving you the capability to have performant and scalable storage with flexible storage sharing, Smart I/O and Smart Tier in Amazon, and the ability to migrate data effectively with our volume replicating capability, as well as our mirroring capability, achieving the right RPO and RTO, and ensuring that we only replicate the blocks of data, not empty space, using all that functionality to provide high availability within a zone, between zones, as well as between regions. And then, of course, if need be, to allow you to use that to support a migration from on-premise to cloud, or provide you with a hybrid cloud architecture to use cloud as a DR target, or even for a deployment in the cloud, use on-premise as a DR target. End to end, we have the tools that you need in order to utilize Amazon successfully for your core critical tier 1 workloads. So with that, I'm going to say thank you and pass the ball back to Simon.
Thanks very much, Petter. Excellent technical overview there. So I'm going to finish off with just a few slides talking about some of the support that Bytes can effectively give you around the AWS and Veritas messaging and the funding that's out there from Amazon. I'm just going to share my screen. Hopefully you can see that. Great. So as I mentioned earlier, my name is Simon Walker. I'm the Public Cloud Services Director here at Bytes, and I'm just going to be going through the practice at Bytes essentially to give you an idea of the journey. Many of the people on this call, some people are going to be in Amazon, they may not have started using Amazon, or somebody might be in between. So we've developed a whole range of services that we offer in-house. So the Amazon practice now is around 45 people, and all we do in this practice is focus on Amazon, working with partners like Veritas to support customers that are looking at the more hybrid option or migrating to cloud and using kind of Veritas technologies to support that migration. So in terms of what we do, and depending on where you are on the journey, we have a methodology for each of those areas. So customers that are kind of just looking at the cloud, maybe just looking at the cost of moving to the cloud, we have the assess phase where we can effectively look at what the costs are currently on premise and compare that to what that might look like in AWS. And depending on the size and the scale of the potential target migration, we can look at what funding is available for that. The actual assess phase is typically funded by Amazon, whether it's under one of their major funding programs or one of their smaller funding programs. We can typically get funding for that. So if you are interested in looking at what we've discussed today in a bit more detail, and you want to kind of get the idea of costs of what it might look like, then feel free to reach out to your account manager and we can talk about assessing that and building a TCO for you. Once we've kind of done that, and again, it does depend on the scale of where we are, we can look at discovery. So that's kind of going into more detail, asking more questions, formalizing. You might have identified other workloads along with some storage and backup or DR that you might want to migrate into AWS as well. And then we kind of build out a bit more of a frame, a picture of what that's going to look like. And then we move into the mobilize, which is kind of test and dev, POCs, making sure that what we've proposed is going to work. And again, on larger scales, all these phases are typically funded by AWS as we move along the cycle. And then we maybe move into the migration, and that could be data migration, it could be infrastructure migration, it could be a DR project, whatever it may be, depending on the scale and the size of it. Again, we would look to get funding for that. A lot of organizations come to us looking at modernization aspects. And modernization comes in loads of different forms. It can be what we've talked about today, moving from tape backups and traditional backups into an AWS type backup technology with all the different tiers of storage, plugging in machine learning and other aspects that you get when moving to a global cloud platform. One of the focus areas that we launched our AWS practice on is around cost optimization. So a lot of the feedback we get from customers, they're often concerned about kind of climbing costs within AWS. So Bytes are a solution provider for Amazon. So we are able to do billing, and Amazon actually pay us to do that billing on your behalf, and we wrap a whole bunch of tools to mitigate risks against cost creep within the cloud. So we can track, build cost centers, build dashboards. And these dashboards aren't just for the technical teams, the finance team, project teams. So essentially we open up the Amazon platform so it's very visible for the whole organization to enable accountability and cost tracking. And where there's cost savings to be made, the tooling itself is intelligent enough to make recommendations. And then we have a whole team of cost optimization and analysts that effectively will proactively reach out and say, oh, did you realize you may have created an EC2 volume and you've got an EBS volume attached to that. You removed the EC2 volume, but you've left the EBS volume in the cloud, and that's costing you money, but no one can access it. It's a very basic example, but it's kind of one of the examples that we often come across, people with lots of disks floating around in the cloud that they don't have access to. Also, we talk about reserved instances, saving plans, and all the other kind of procurement methodologies that you can do within AWS. We also transact EDPs as well, which is the enterprise discount program. So when you hit some scale within AWS, we can negotiate with AWS on your behalf to drive further costs and discounts across the platform. The final element of our services is our 24/7 managed services. So customers that want that additional support. We are a partner-led enterprise support partner of Amazon. So essentially that means we offer enterprise AWS support at a fraction of the cost of what Amazon would offer it at. And also it is cheaper than business support from Amazon. So again, it's an authorized program from Amazon that allows us to offer enterprise support to customers that need it. So if you are in Amazon, you are looking at further support, then again, please reach out to us on that. So in terms of what we've talked about today, so we've branded this service as called Data Shield within AWS, and there's various technologies that can support this migration into the cloud with backups. The Data Shield service really was set up with Amazon, working closely with to take a lot of the pain points away of this. So a lot of organizations that have done this with us already may not have had an Amazon account. They may not want to necessarily get too involved with the AWS, but they really want the benefits of it. So one of the first things we'll do is set up a call. We'll bring on a specialist from Veritas. One of our Amazon architects will be on there, and we'll do a quick survey to kind of gather that information that we need so we can produce a bit of a cost model for you. Off the back of that, we'll produce a statement of work, which will give you an idea of what it's going to cost, how much is the funding that's going to be available, and the timescales that it will take to actually get you into there. And then obviously sign off the project and off we go. And on the left hand side of this slide, you can see kind of the process that we go through, and it does depend on the maturity of the organization in AWS at this time. But typically, if it's quite new, we will build out the VPC for the environment. We'll define the networks for the environment, working with yourselves. We'll create the AMI, so the machine image, which is typically based on Veritas recommendations for whatever they need. And then we start talking about security, encryption, permission, object locking, and that side of things as well. So essentially we can take you through the whole journey, take a lot of the pain away, and then kind of hand over, hand back, or provide some kind of support if you needed support on that environment. But the idea is it gets you off the block very quickly without too much pain. And if funding's available, which it typically is, we can obviously use that to offset any PS costs on our side. And we manage all the processes of getting the environment up and running and working. So finally, I guess just to summarize, and I think this has been said, but I mean, one of the reasons we see organizations looking at this very seriously is on the left-hand side of this slide is kind of some of the pain points that we come across. And then on the right-hand side is how they are addressed by the AWS kind of powered backup using Veritas technologies. So kind of the typical one is waiting weeks or months for resources. I think what a lot of organizations don't realize is when you run out of disk space and you disk arrays and you take backups and all that side of things, you just look at, okay, well, it's going to cost me X amount for a disk. They don't look at all the procurement costs. They're going out and getting 3 quotes. The engineers that have to be scheduled to replace the disks, maybe faulty disks coming in and they're not quite working, sending them back. All those costs really do add up. And then within a TCO, they're often missed. You just look at kind of what the cost is versus what the cost is in the cloud. And that's not the way to look at it. In terms of durability, it's another big area. Obviously, with 11.9s, as Tom mentioned, to store backups, it's hugely resilient. The security aspect of it is key. Obviously, Amazon invests millions and millions and millions in their kind of infrastructure, physical security, and obviously we can support with the actual kind of software security and build security around that. And the final part, which is I think one of the most exciting things and things that can really add value to the business and other parts of the business, is actually doing stuff with that backup. As the team Veritas kind of explained, you know, they've got services and products that can actually analyze that data and start making it more valuable. So it's not just sitting there idle, not really doing anything. You can effectively do stuff with it, which will add value back to the business. Which again could be added into the whole overall TCO of using the data as opposed to just having it sitting dormant doing nothing. And that's it from me, so nice and quick. So I think we said we're going to have a few minutes for questions. Cassie, I don't know if you've got any questions lined up or if we've got any through on the chat.
Yeah, I think we had quite a few coming in earlier, which were actually Tom and the team were doing a great job in just sort of going back in the chat and responding. So if anybody does have anything they want to ask now, that's, you know, pop it in the chat box. Which is with regards to what you were saying, Simon, someone has asked, is there a link to an example of the dashboard, for example, finance that you could provide?
Yeah, so if we can just get your details, we can send you across the kind of the data sheet. We show you all the different kind of dashboards that you can build, but you can build CFO dashboards, CTO, finance, and then you've got the technical kind of dashboards that we can build. It's all based on how the environment's tagged, but as part of onboarding you onto the kind of SPP program, we would effectively deploy the tool, give you a run through, train you. In most cases, it's free as well, because as I mentioned, Amazon will fund that service for you as part of the billing. So there's no real disadvantage to it. The only difference is the bill would come from Bytes as opposed to Amazon, which most customers see as a benefit, because we give you a much more granular bill on the actual resources and who's using those resources. So we can certainly support you on that and give you a demo.
That's great. And if anyone else has got any questions, please do pop them in the questions box. We'll obviously be sharing the slides, and there will be a copy